I'm Simon Briggs and welcome to the ROSA and Beyond virtual event. I work for Red Hat as a ecosystem solutions architect, which means I work dedicated to the AWS partnership to help customers be able to consume the technology from Red Hat that's available through the AWS route. Because of that, I'm very focused on the Red Hat OpenShift Services AWS technology. Of course, security is an essential capability of Red Hat OpenShift Service on AWS. The way that ROSA is secured and delivered is industry leading. We base all our solutions virtual machines delivered on the highly secure EC2 platform from AWS, all on our CoreOS operating system, which is a specially customized derivative operating system based on Red Hat Enterprise Linux. CoreOS is an immutable operating system, which means that no software can be placed on that operating system without killing the instance that's running and restarting a new one based on an image with the new software built in. That gives our customers great confidence that there's no way of injecting software nefariously into that running operating system whilst they're using ROSA. SE Linux is also configured and deployed on the instances running ROSA to make sure that no processes can be hijacked. There are several other key operating system security benefits within the tooling. And then on top of that, the Kubernetes delivered within OpenShift has even more security elements built in. That means you can be assured that ROSA is the most secure Kubernetes development platform available to you in the market today. As you can see, I've already built out a demo ROSA cluster for me to work with today. But if I want to extend the already powerful security controls I have within ROSA into the applications I want to deploy on top of this platform, I need to think about other aspects of security. When discussing risk in context of Kubernetes-based services, we often explain that the security process should really shift left. And what we mean by that is often security isn't thought about in the development process as a high priority to fix, which leaves organizations to have to engineer those fixes that are required from a security point of view into already existing performant production platforms, which is very expensive and risky. So we talk about shifting left further into that development process. And that includes being able to integrate tools like advanced cluster security into CI/CD platform, DevOps processes that you build as a development organization. To assist with that, the tool actually gives great visibility to security managers. And one of the fundamental elements of that is to assess what vulnerabilities the images that are being used within a service actually exist. And to do that, we scan images using the common vulnerabilities and exploits database that is an industry standard, which gives management teams a rapid understanding of what vulnerabilities are exposed within their service platforms. As you can see here, we drive it up into a very easy to understand logical dashboard. And at any point, we're giving qualitative information to the user to explain, for instance, where the images could be fixed and be able to give them an understanding of which are the images that pose most risk to the organization. You can drill down at any point to have a look at the individual components that are highlighted and be able to then guide your assessment on what is best to be able to secure those particular components. But importantly, we're not just identifying vulnerabilities. We're actually building on the understanding that ACS scanning gives us around vulnerability to derive what we call a risk score. And that risk is, again, qualitative information which allows organizations to understand whether or not particular vulnerabilities or exploits combine with configuration to actually put that service at risk of attack by outside nefarious elements. And here you can see very easily that what we've done through the risk analysis is build up a priority of status for the particular element that's at risk. And you can drill down and look at the particular vulnerabilities that are within this element, but more importantly, combine that with the configuration of the service, maybe the storage, etc., that might be set up with the platform, and also the networking capabilities. Is this component within your platform exposed to the internet in a way that allows attackers to be able to come in and exploit those vulnerabilities that we were talking about? What we can do is also then take that information and analyze running processes with the same understanding in mind. So we have process discovery of any pods that are running in the environment, and if there's any exploit taking place in the environment, we'll be able to rapidly flag up using what we call policies that behavior is happening on that pod which suggests there's been an exploit, and we can apply those policies proactively to hamstring any attacker. And that brings in our policy configuration capability. Within ACS, there's a standard deployment of policies to organizations. They notify and can take direct action and help identify remediations that can take place against particular security risks. And you can design and build your own policies or augment the ones we have to suit your own use profile better. That all builds up to allow organizations to apply compliance scanning against a particular environment. And within the ACS tool, we've got libraries that allow organizations to compare their status against particular appliance requirements, for instance, HIPAA that you can see here, or NIST, and we can very quickly give evidence to organizations that you either comply against those particular compliance requirements or have to do some work against your platform to be able to satisfy those. A great new feature of the technology is the ability to use a network graphing tool, which helps visualize the communication between components within your Kubernetes platform. If I highlight some elements within a demo app that I've been running here, you can see very quickly we're mapping the communication across ports within the environment. Importantly, within Kubernetes, there's a native API construct called network policies that acts as a firewall that can be configured, but is complex and often difficult to utilize. To simplify this, we have a capability within ACS to identify that no policy rules are being run at any point. And we can use the Simulate Network Policy button to help us be able to generate the code to be able to apply those network policies against those elements to give you further security. And the great news for you as customers of ROSA is you can enable a new cloud service that Red Hat's delivering for this Red Hat Advanced Cluster Security. As you can see here, I've got an example of my marketplace where I've subscribed to that service. Then I've simply, to enable that, I've gone across and set up an ACS instance and connected it directly into the demo ROSA cluster that I showed you earlier. It's very easy to utilize and gives you all the power of the dashboarding I've gone through earlier in this video. So hopefully you enjoyed it. Please keep an eye out for the new material that we're releasing all the time into the ROSA Beyond environment, and thank you for your time.